All right, let's talk about application of the scientific method. It's my thought that the scientific method is actually how our brain works. Our brain does things like solve the problem and all these kinds of steps very logically. So let me prove that to you by doing the following. You've either at your house, you guys struggle with losing these or these or these. Okay, almost every house has that struggle. Okay, you either lose your cell phone, your keys, or your remote. Now, if you lose your remote in most houses, you turn the house upside down to find it because it's usually of the big TV that everybody's trying to watch. Okay, now I want you to think about how that happens. Okay, somebody says, "Where's the remote?" And you're like, "I don't know." And all of a sudden, everybody starts searching. Do you go look in the attic? Do you go look in the backyard? Do you look at your neighbor's house? No, those are illogical places. But your brain goes through this logical progression of where did I see it last and what do I do to solve that problem. So I'm going to take an example. For most of us, we're about to start driving. Some of us already started driving, and some of us are about to start driving, and so you're going to have your own keys. It's pretty cool to have your own keys. But it never fails. You end up losing it or setting it somewhere. So let's take the following example. This is how your brain works, but this is not how you do it. Where'd my keys go? Mother, I've lost my keys. State the problem. I've lost my keys. Form a hypothesis. I believe that due to my unkindness of sharing my keys with my family, I have put my keys in a location in which I will now find. I think my keys are going to be found in my bedroom. I will now form an experiment in which I will turn to my left. I will walk left, right. I will reach with my right hand to the doorknob, turn the doorknob, open it, walk over next to my bed, look next to my bed, and then I will find my keys. Collect and analyze data. I've looked. Conclusion, they are not there. I was wrong. Now, that would be a silly way to do the scientific method, but I want you to think about what I did in a really silly way. See, if you do things like that, what's going to happen is your parents start freaking out. Like, why is he doing that? Why is she doing that? See, they'll put you someplace where your arms are like this all the time, and people will have to come visit you, and the walls are all padded. See, we don't do things like that. See, we've learned real quick you don't talk out loud to yourself all the time, right? And so, in a silly way, that's really how the scientific method works. As soon as we have a problem, I don't know where my keys are. Your brain says, I think I know where it is. It's a hypothesis. It's an educated guess. And you go check that. That experiment was very quick. I walked to my room. I looked for it. Conclusion, it wasn't there. Is it over? No. I repeat the problem. No, I don't repeat the problem. I have the same problem. Repeat the hypothesis. Now, your next hypothesis might be something like, it's in the kitchen in the freezer. Now, you may think that's a really weird place for it to be, but I've had kids, and here's what happens. When the door opens and you come in from school or other event, there are two places you go, refrigerator or cabinet. And you're laughing because you know that's exactly what you do. And so the chances of you setting them there is a really good chance. So you go in there and look, I didn't find it. Go place to place and place until you find it. Logical places. When do you stop that cycle? When you've solved the problem. Now, our brain works like that on solving a problem. And there's lots of examples. Lots of examples. That's just a silly example of how we use the scientific method. Now, scientific method is used in science, an organized way of solving a problem. See, for a really, really long time, people used to just look at the world around them and say, I believe things like this. Here's a real one that was published. People used to believe that frogs came from mud. If you take mud and you smash it together, you get a frog. And it was very logical because you only saw frogs in mud. Now, you and I know they're amphibians. They have to have wet skin in order to breathe through that, and they have to be wet. If they dry out specific type of frogs, they'll die. So people are walking around near their pond on the back part of their property, and they're like, oh, look at the mud move. Oh, it's just a frog. Frogs come from mud. It was very logical in the 1800s. That's where it came from. And so we know that's so untrue and not true at all. But that's what they believed, okay? Here was another one. This was actually published in a book by a doctor. You have to follow this one. If I take an old jar, like an old pickle jar, okay? Take a jar, shove an old dirty shirt in it, and then I grab a handful of grain, corn grain of some sort, throw it in there, and go put it in my barn. Leave it there overnight. When I go the next morning, the grain, the corn, has now turned into a rat. Now that's logical in what they saw. Because if you took that jar and you put some cloth in it or a shirt in it and threw that grain in there and set it in your barn, you made a nice little home for the night for that rat that's running around looking for food. He climbs in there, eats the food. When you open the door, I see the rat. There's no corn. The corn turned into a rat. It was very logical. And finally, they got to a point where they were believing such incredibly weird things that they finally had to decide, we need to start logically solving problems, not just logic. We have to use more than that. And so that's where experiments start coming in. Okay, one of the very first experiments, they used to believe that flies came from rotting meat. Okay, so when meat is rotting, okay, we know that flies, they lay their larvae, their little eggs on there. Okay, you've seen them, they break open, they're called maggots, and they live off that until they break open and they become flies. Sort of like a caterpillar becomes a butterfly, a maggot becomes a fly. But they didn't know that. They thought flies, maggots, come from rotting meat. So you had to be careful with the meat so the meat didn't rot because the maggots would come out of it. And so one of the guys said, we're believing some crazy things. Frogs come from mud. Corn can turn into rats. So what he did was he set up an experiment. Very simple. He had 3 jars. In jar number 1, he put a piece of meat, no lid on it. Jar number 2, he put a piece of meat in it with a twisted lid on it. In the third one, he put meat in that jar, but he put a piece of gauze over it. Now, gauze that really thin, sometimes when you hurt yourself, you take that thin gauze and then you'll wrap bandage around it. Okay, really thin like that so air can go in and out of it. Okay, so he laid his experiment out. Now, if flies and maggots come from rotting meat, where would you find maggots as the meat got old? In all 3 jars. If the maggots come from the rotting meat, as the meat got old, you would have it in all 3 jars. Do you think he found it in all 3 jars? No. He only found it in jar number 1, where the flies could get in. Now he thought, okay, so why are there maggots here? But in the jar with the lid on it, there was nothing. The third jar is what helped him. He noticed there was flies swarming around, and they would land on top. And as he looked really, really close, he could see the little eggs that would become the larva. And he realized, no, maggots don't come from rotting meat. They come from flies laying their eggs. So he set up an experiment. In that experiment, do you know what jar number 1 was called? It was the control. It's the control. It's the one that I control everything about, and then I can look what's happening here and look what's happening here, and I know I have my experiment. My data comes from jar 2 and jar 3. My control is the one I don't do anything to. And so he basically, when he published his results, he said, we need to stop using just logic and looking at the world and trying to figure out how it all works. We need to do experiments. And so from what I've told you in this video, the logic, how we solve a problem is the scientific method. They're written in rules so everybody follows the same thing. If you're a person who's trying to solve a big disease like cancer or a specific type of disease, whatever the case may be, they're going to have to get a group of people, and a group of people, one's a control group, and the other group they're going to try the medicine on. And it may take months for them to take the medicine, and then they're going to compare all the data, and they're going to try to figure out if the medicine works, is it the right dosage? For some people, it makes them sick. Why? And you hear those on commercials. If this makes you this, then stop taking the medicine. And so they do experiments till they find something. Now, the most important thing I'm going to tell you is in that little scenario where I had my keys and I had to run to my room and I went to find my keys and they weren't there and I was wrong. There's nothing wrong with having a wrong answer or data that doesn't work. Because every time you're wrong, it gets you one step closer to having the true answer. So they haven't solved, for example, the cause of cancer. They're getting closer. Every different type of thing they try that doesn't work, that almost worked but not enough, let's try this. Every time they're wrong, it pushes them closer to the truth. Okay? And so science is constantly trying to get fact. What is real? Okay? And in the last video when we talked about the steps, when you do that cycle until you get the answer, sometimes in really big things in your experiment make weeks or months at a time. To do it, maybe years to get your results. Sometimes you have those theories, remember that word? And then sometimes you have laws. Those laws, it doesn't become a law immediately. It has to be a theory until they can prove there's no exceptions to it at all, and then it could be a law. There are some things that become laws. There's not very many of those in the world. But the scientific method, very logical way of solving a problem. In the next video, you're going to watch as an example from a movie. One of my favorite movies, I think it's the best movie ever made. It's called The Sandlot. And The Sandlot are some boys, if you've never seen it, some boys who are playing baseball in the summer. And they lose their last baseball. They hit it over a fence to where there's a dog. They can't go get it. It's too big of a dog to go in the backyard. And so one of the boys runs home and says, I got a baseball at home. Runs home and they're playing with it. And they hit it over the fence. And they realize the boy said, oh my gosh, that had a signature on it. They're like, who signed it? And they find out it's Babe Ruth, a legendary baseball player. And so now they have a problem. How do we get the baseball back? And so you're going to see the scientific method play out in the next two clips on their experiments of how to get the ball back.